Yeah, thanks for inviting me. My name is Dietmar Offenhuber. Those are definitely tough acts to follow, but I also want to start by briefly remembering Gerhard Diermoser, who passed away last month. And in many ways, he was like a prototypical data artist. His research was on diagrams, or diagrammatics, as he called it. And he created these huge and complex posters on subjects of philosophy, atmospheres, performance art, as he's in like Boris Nislony's exhibition. And in a way, he also performed his exhibitions in some sense. So he was motivated by this question: how can diagrams express forms of meaning that are hard to capture in language, and how can we use diagrams to think with other ontologies, let's say like fluid or like more atmospheric ontologies? So for him, it boiled down to the question: hat das Zueinander eine Form? Does the towards each other have a form? And Zueinander is a very ordinary German word that you cannot translate, to my surprise, to English, because the English terms are way too specific: correspondence, juxtaposition, orientation, alignment, connection, in between, and so on. Zueinander means all of that, but it's not as abstract or general as relation. It emphasizes the presence of the entities that are set in relation. So, but essentially, he's talking about a relational approach to meaning, which brings me to my topic of data as an artistic medium. So most of what we heard and most accounts on data or artistic projects of data, which includes also the critiques, focus on the data content, on everything that is explicitly encoded, the thing or the person or the idea that a data point represents. And so this representational concept of data considers a data value as static reference, as a description of the world of some sorts. But which is, of course, very important, but it also means, if we only focus on that we miss a lot of really interesting stuff in this Zueinander, which is relegated to context in this referential model. So how are data made? In what are the infrastructures? What are the material conditions and practices that are involved? How are data used rhetorically as evidence in debates, as we've seen in Paulo's presentation brilliantly? But also how data act as material objects, not just surface descriptions, what Andrea talked about. So we can capture a lot of that as metadata, but at some point it gets really unwieldy. Alternative is we can also think about a relational concept of data, where a datum is considered a part of the phenomenon, not a description of it. A data point is always material and interacts and interacts with the world. And this includes both human relationships, how data sets are passed around, but also the material relations and conditions of data production, which is like what I'm interested in here. So I'm not dismissing the representational function of data. It's very important, but we miss a lot if we only focus on that. And as we heard, data produces its own world and then basically substitutes it. So that has its own dynamic. So my own work has mostly focused on these relational aspects of data using material perspectives as a form of critique. Give you one brief example. This is a project commissioned by a festival in Stuttgart, and they actually asked me to make a project that uses big data in collaboration with a local supercomputing center. And I did something very different, which may be the reason why I'm not often invited back. But so Stuttgart is an interesting place, has a big problem with particulate matter air pollution. And there's an ongoing public controversy around the topic. So the city has a sensor network, but many citizens, activists think that this does not really capture the problem. So they created their own sensor network. And what is interesting in that dynamic is that the debate quickly shifts to the technicalities of measurement, so away from the content of data to how exactly was it measured, and what do we accept as an accurate measurement and evidence. And This is a very general theme that I see in all big controversies of today, like from climate change to political misinformation, that it's not really about the data content or the interpretation of it, but about the data origin, like how are data generated. The problem here is that visualization cannot really help us with that, because visualization can only start once you have data. So I was looking at different ways. So, for example, looking at the materiality of data production with particulate matter, there are many different ways how to measure it. The city usually uses this gravimetric measurement where you basically just collect the dust on a filter and then put it on a scale. The US EPA uses as kind of a simpler, faster method that uses like radioactive absorption. And most DIY sensing communities use this kind of optical scattering, which is technically very simple and reliable, not totally accurate, but good enough, that uses basically a laser beam to count the particles that it crosses. So since the number that you get from this sensor does not really give you the material context, I was interested in ways to bring it back, looking at the city itself as a visualization of air pollution. This is an example from Paula, who pointed out, like in Grand Central Station, the restorers left this, unfortunately you can't really see it, the restorers left the spot to show how the ceiling looked like before it was restored. And this is essentially cigarette smoke, and cigarette smoke is particulate matter. So in a way, you basically have a very clear comparison. And this is pretty much the strategy that I chose for this project, to use this kind of reverse graffiti method in places where these sensors are placed, to invite people consider the correlation between the patina of the city and the sensor outputs and the sensor readings. And so, like, is there a correlation? Do we see that? It also fades away over time. The pattern is designed in a way that, like, there are some parts that disappear easier than others. And now you can say this is actually a terrible form of measurement. This is not, like, in any way comparable to even the cheapest sensor, which is, of course, true. But when you say this, you are formulating a material critique that in a way relies on you understanding exactly the material process of measurement that you don't really have access to if you look at the sensor only at the black box of the sensor. So this is a little bit the idea of what I was trying to get at. So this is an idea called autographic design, which I conceptualize as a mirror image of data visualization. So in visualization, you start with the data, and in autographic design, you end with the data. In visualization, you kind of visually analyze data in order to interpret a phenomenon that, however, is a little bit disconnected because we focus on the data. In autographic design, you start with the phenomenon and then visualize the emergence of data in order to contextualize it with an analysis that might come from visualization. So a key here in this, like the autographic part, is this notion of self-inscription or autography. And in my view, all data, whether analog or digital, share that they carry traces of data generation. And these traces are often involuntary and unrelated to the data content. If you want to know more about this design framework, there's a book that was published at MIT Press in the metaLAB series. So you might want to know or ask yourself, what do I mean when I say also digital data carries digital traces? And this is a quick example. This is open data from New York City, all the GPS units from taxi cabs. And if you just plot it, unsurprisingly, you see a map of the city emerge. But you might notice that some areas are more blurry than others. And, Well, how can that be? We see more noise in some areas than others. And in order to figure out what's going on, we can ask ourselves, how does the city look like in these areas? There are very tall buildings that generate a lot of GPS noise. Not surprising, but the interesting thing here is that now we have information about the three-dimensional shape of the city, even though we just have two variables. And the interesting thing is that we can use this information only if we consider the materiality of the data source, if we are willing to accept noise as information. Another example here is the animation I did with Azraq Shamia. The topic here was the sky as a navigational device. It's a little bit hard to show because it's a 360 video that is very narrow, and it consists of multiple parts, but the one of the film I'm talking about uses astronomical data from Simbad from city of Strasbourg University. So every white dot that you see here is a bibliographic reference to an astronomical object in a particular year. Here you see the titles. It's unfortunately hard to see. Published over the past 170 years. So over the years, we see these kind of patterns emerge. We see these kind of boxes and scan lines. Those are the modalities of publication. So there are star catalogs that appear in different editions and are updated, and every year a different portion of the sky is published. We also see traces of instruments. And as we get more and more data, we also see features of the sky. So we have like the Milky Way, the center of the galaxy, Magellan clouds. So we have a lot of kind of inscriptions just in this bibliographic data. Yeah, here are the most common objects, highly referenced objects. So, yeah, you may ask yourself, why does this have to be so ugly? So like what I try to do is really to just have remove the design interventions as much as possible, to really just have one bit information, one white dot for every reference and nothing else. And I want to call your attention now to this little matrix on the upper corner. People who work with astronomical data might recognize this as the Kepler data. There are also other patterns. There are these kind of vertical streaks here that is kind of hard to see, but those are me hitting the download limits of the SQL base. So like I also introduced my own traces into the data set. But back to this feature, this is data based on data collected by the Kepler Space Telescope. This is how it looks like. It always looks at exactly the same spot in the sky because it's hunting for planets, so it has to do these like long-term observations. So this is the image sensor of the telescope. And here we see this kind of bibliographic imprint in the bibliographic database. So it's kind of remarkable that even this kind of this black lines that stem from these structural objects that prevent the sensor from warping left a trace in the publication record, just in the fact that no planets are being published in that spot because some engineer decided to design it that way. So this, of course, is none of that is really surprising, but it just shows how far these kind of material inscriptions go. And the point I want to make is that there's a lot of hidden information in data that we can only get when we consider the materiality and also the social practices and political aspects of data collection. So what we know about the sky depends on the ideas and design decisions and worldviews that were put or baked into the instruments and the publication modalities of journals. So last project, we can use these kind of autographic phenomena not just for figuring out what happened, but also as a medium of computation. So there's a long history of analog computers. I want to finish with a project currently on show in the Arsenale of the Venice Biennale, for which we built a water computer that uses the water ripples as a medium of computation. There's a long history of water computers going back to antiquity. Those are two 20th century examples. And there's a lot of interest right now in analog computers because they use a fraction of the energy necessary for AI models, or for more generally for digital computation. So what our computer does, it calculates the time of the day based on the disturbances of water surfaces on the canals of Venice. And it's based on this principle of physical reservoir computing, which is a current area of research where part of a deep neural network is replaced by a physical phenomenon. Here you see some parts of this installation. So the water ripples are used to transform the input data in a nonlinear way and to make it easier to sort out the different patterns. But what we argued is that you can look at the entire city of Venice with its interconnected canals as a reservoir computer, where the wakes and the water disturbances from the motorboats, vaporettos, propagate through the canals and act as a short-term memory of urban activities, very much in this paradigm of reservoir computing. This is from the setup. But just to conclude, the relational approach to data focuses on the latent, focuses on the implicit, and on the actions connected to data rather than on the descriptions and representations. So not that representation is not important, but once we focus on it, everything else disappears. And I would argue this kind of latency is something that artists are very good at dealing with. And as for Gerhard's question, before his death, he found an answer that he was satisfied with. Das Zueinander is the form, the towards each other is the form, and the meaning of the diagram is in the space between its elements. Thank you.